Hello everyone. Welcome back to the next training session of SHL Technical Support Team. Today's content we want to introduce to everyone about heat treatment oil. In this chapter of heat treatment oil, we will learn about the following contents. Part 1. Definition and characteristics of heat treatment. Part 2. The types of heat treatment. Part 3. Cooling performance test and cooling curve. Part 4. Kinds and used of heat treatment oil. Part 5. Changes in brightness. Part 6. Selection method. Part 7. Development of heat treatment oil. And finally, management of heat treatment oil. Due to the content of many parts and limited time, in today's session we will introduce everyone to the first 4 parts of the chapter. Let's learn the first part, definition and characteristics of heat treatment. Heat treatment is a process that uses heat to change properties depending on the purpose of use of metal. The structural change occurs through rapid heating and then cooling. The main heat treatment process characteristics include hardness and strength improvement of material, minification and stabilization of tissue, material surface hardening, and tissue softening, improvement of processing performance. Principle of heat treatment is changes in structures and bonding of solid metals due to heat. Regarding heat treatment methods, there are 4 main methods include quenching, tempering, annealing and normalizing. The quenching method is a method of heating the metal above the upper critical temperature, then keeping the heat to stabilize the martensite structure and then quickly cooled. This method increases the material hardness but in terms of low ductility. The second method is tempering, which is similar to quenching but is heated to below the lower critical temperature, keeping the heat for a while so that the metal structure is evenly distributed and then cooled to room temperature, to increases the ductility of the material. The next method is annealing. Annealing is to slowly heat the metal to a certain temperature, then hold the heat for a period of time, and then cool it slowly with the furnace to room temperature. The method helps to eliminate the internal fracture and increase the ductility of the material. And the fourth method is normalizing. Normalization is that we heat the material to a temperature above the critical temperature from 30 to 50 Celsius, then hold the heat and cool it in air. This method eliminates internal stress. Next, about cooling performance test and cooling curve of heat treatment oil. A simple laboratory test method that includes silver stick, furnace and oil sample. The material is heated in a heat treatment furnace first, then the material is rapidly cooled in a heat treatment oil. The process from the time the oil is added to the time it is removed from the oil is recorded in the curve graph as shown in the figure. When the material at high temperature is put into the oil bath, first, an oil film will be formed on the surface of the material. Then under the high temperature of the material, the oil film gradually bubbled and replaced by the next oil film. At the same time, the temperature of the material rapidly drops to a temperature where no more bubbling occurs. This point is called the characteristic temperature. After this point, the material temperature decreases slowly and is plotted as shown below. The time period to reduce the temperature from 800 to 400 Celsius on the graph is called cooling time, travel time. Regarding kinds of heat treatment oil, there are 2 ways to classify. The first way to classify according to oil temperature is divided into 3 types, which are cold type, semi-hot type and hot type. The cold type has an oil temperature of 50 to 90 Celsius, the semi-hot type has a temperature of 90 to 120 Celsius, while the hot type has an oil temperature of 120 to 160 Celsius. If divided by type of oil, it can be divided into 2 types, water-soluble oil and water-insoluble oil. Each type of oil has its own pros and cons. SHL's water-insoluble heat treatment oils are typically 2 types, Quench 100B and Markin CH100. This type includes base oils and additives. Typical SHL's water-based heat treatment oil is Sol Quench 7. Regarding the advantages and disadvantages of these 2 oils. The advantages of water-insoluble oil is eco-friendly, reusable, superior cooling performance, high fire point and excellent oxidation stability. About the disadvantages of water-insoluble oil, the cost is more expensive and the risk of fire and explosion is higher. With water-soluble oil, the advantage is low risk of fire, low cost of steel available, less environmental pollution, easy to post-treatment and non-toxic, easy handling. About disadvantages: with water-soluble oil is corrosion of quench tanks, cause microbial growth and cooling ability is lower than water-insoluble. Above are the first 4 contents of the heat treatment oil we want to introduce to you in today's session. The next session we will continue to explore the remaining contents of this chapter. Thank you all for listening. If you have any questions or concerns, you can contact SHL Technical Support Team via the email below. Thank you and see you again.